Welcome to Unacademy, India's largest online learning platform. India's largest online learning platform. Good evening, Srinivas. Good evening. Welcome to Unacademy. I missed you. I missed you for a couple of days. Hope you were very busy with your some other work, right? Welcome. You inform your other friends also that the live is started. Srinivas Rao. So this is a crash course on analog electronics, a crash course on electronics. So today we will start the class from 3:30 p.m. Mostly from 3:30 p.m. will be there. So from tomorrow again for the next 3 days will be at 4 p.m. only because the festival is there. So but still we will be continuing this class. Bharat, good evening. Damu, good evening. Okay, thank you. I love my students also always because you will give a lot of inspiration to me. If you guys are listening to my classes and getting benefit out of it, that will give more satisfaction to me rather than anything else in my life. So your betterment is my success. Our success depends on your success. Thank you, Damu. Okay, welcome to the class. So today we are going to discuss about important concept. Till yesterday we have discussed diode circuits. From today we'll be discussing about bipolar junction transistor. Bipolar junction transistor. Okay, so this analog electronics is a crash course now. So which will be useful for the students of ECE, EE, and instrumentation also. Instrumentation also. Instrumentation also. Okay. Now, so myself, Shravan Kumar, I have master's degree from JNTH in VLC system design. So I have 10 plus years of teaching experience. And then I can teach the subjects EDC, analog, digital, and EMFT. As I told you, EDC, I've almost finished 40 plus hours on YouTube, and I'm teaching right now on Unacademy app. Unacademy app. Those who did not download the app, please download the app and follow me so that you can listen to my EDC class also. And analog electronics is a crash course. As I told you, as I promised, I'll be definitely finishing before 31st of January so that you can answer all the questions in the GATE examination. Right? So while you are writing a GATE examination, my voice will be there in your background, right? So EDC and analog. So for this 2021 GATE, I'll be giving at least 20 marks. So from my side, I'll be giving 20 marks for you, right? So if you listen to my all the classes and follow me properly, you'll get 20 marks. And digital and EMFT, so targeting 2022 and 2023 students, we will be starting this once the we enter into February, right? Damo, I'm not much worried about my benefit. I want you to be benefited. I want my students to be benefited out of my classes, right? So that gives me a lot of energy. That gives me a lot of energy. Okay. So SVS 10 is the code. SVS 10 is the code which will give you 10% discount on plus subscription. So plus subscription. So what do you mean by plus subscription, sir? Plus subscription is nothing but you can attend the live classes. You can have the crash courses. You can write the weekly test, which is very important. All the time I'm mentioning writing exams is very important than just reading in GATE examination. In GATE examination, right? And you'll have every fourth hour is going to be a doubt solving session. It is just like your normal classroom. You can question all the faculty at any time and you can get a benefit out of it. Right? You can clarify your doubts. And sessions will be in English and Hindi. Sessions will be in English and Hindi. And you have something called rank improvement batch. You have something called rank improvement batch. People like you who are very strong at the basics and got some rank and looking to improve their rank. So this rank improvement batch will be useful. This all comes under a plus subscription. We have another subscription called Iconic subscription. So apart from all these benefits, you'll also have some extra benefits for an Iconic student. So the important thing is you'll get a personal coach. You'll get a personal coach, and then you'll have a study planner. You'll have a study booster sessions, and you will have a personalized test analysis. So after writing every test, for every question, you will be given an in-depth analysis. In-depth analysis will be given. And then you have something called preparatory study material. You'll have something called preparatory study material, which is also very much important. So what is the fee structure for the Plus subscription? You have a 12-month subscription, 18-month subscription, and 24-month subscription, right? So somebody who wants to go for 12-month subscription, the fee is going to be 27,225 rupees. It's going to be 34,650 rupees for 18 months, and for 24 months, it's going to be 39,600 rupees. Sir, this fees is very less when compared with your physical classes, right? So they'll be charging in lakhs of rupees, thousands and lakhs of rupees. It is almost 50% of what you will pay for 1 year, right? Almost going to be 40,000, and again you have a benefit of using my code to get 10% discount. To get 10% discount, sir. So just think about it. You'll definitely crack gate examination if you register for this. If you register for this, okay. And iconic subscription there for 12 months and 24 months. So the fee structure is going to be 45,225 rupees and 66,600 rupees is for 24 months and 12 months subscription. Again, you can use my code SVS10, and you can pay through many channels. I think in the next slide I'll try to explain you how can you pay the amount. How can you pay the amount? Simple. First thing is you need to download Unacademy Gate learning app, Unacademy learning app, and then you should install. So in your mobile you will have a lot of other apps also. Just think that this is also another app, right? So the third step is going to be manage your goals. As I told you, we are spread into many things. So we have net exam, gate, ESC, IIT jam, NEET PG. So as we have many other areas also we are spread. So I would request you to select the gate and ESC. Once you select gate and ESC, then you will be given an option of plus subscription, free courses and special classes. These are free classes which are Unacademy is giving. No other online platform is giving this best opportunity for the students to learn from the top. And plus subscription, click on the plus subscription, and then you will be given get subscription. So what is the get subscription means? So you should choose 12 months or 24 months duration and use this. Now type this code of SVS10 and apply. Then you'll be going to choose payment method. There are different payment methods which you have. You can pay using debit card, EMI, UPI, wallets, and net banking. So whichever you want, you can pay. Whichever you can't, you can pay. This is the best option to do that. And you can all follow me on Unacademy for all the updates from my side. And this is one important thing. Today 6 p.m. After my class, today 6 p.m. you'll have a test, Unacademy combat test. So which will be on today, January 12th, 2021, 6 p.m. So you can register for free of cost. There's no fee for this, but you will have a code called SVS10 to attend this exam, to attend this online exam. What is this online exam? It's going to be India's largest fortnightly. For every 2 weeks, we will be conducting this gate exam, online gate exam, and this will be there for 65 minutes. And you will feel that original questions from gate examination, and you can have a live compete board. You can compete with the top of the best students in India, and this you have a fun also. So depending on your fastness. So your leaderboard will be changing. All India leaderboard will be changing continuously, and you will try to answer the questions very quickly, right? So you have a very important thing here, sir. After completion of the exam, so you will be provided with the detailed video solutions. You will provide the detailed video solutions. The students of mechanical, civil, electrical, electronics, and computer science and information technology students can participate in the examination. So what are the benefits of this? So the student who will get the rank 1 will be given a 3 months free subscription for GATE and ESC. Plus subscription will be given, right? So the student who will get rank 2 and 3, they will be offered a 1 month GATE and ESC plus subscription for free of cost. And then the student who will score or get rank 4 to 100, they'll be given 500 rupees Amazon voucher. 500 rupees Amazon voucher. Okay. Yeah. So now we'll start our discussion. Something called bipolar junction transistor. bipolar junction transistor. Here, the most important thing to be remembered is the transistor will be having three terminals. The bipolar junction transistor is having three terminals. It's a three-terminal device. The three terminals will be emitter, base, collector. If you recollect from your diode, a diode is having how many terminals, sir? Will be having two terminals. One terminal is called anode, the other terminal is called cathode. But here, the transistors is having three terminals. One is called emitter, the second one is called base, and the third one is called collector. Base, emitter, collector will be the three terminals of a bipolar junction transistor. I'm not going to talk completely about the bipolar junction transistor here because its concept and everything will be discussed. This concept will be discussed in EDC. Here, our discussion will be more on the functioning and analysis of a BJT circuit. Our discussion will be more on analysis of a BJT circuit rather than on how it is constructed, how it behaves, or different things. Right? Of course, we'll talk about different modes of operation of bipolar junction transistor in detail, but we'll be not discussing about its construction. It is a part of electronic devices and circuits, that is EDC, right? So that will be EDC. Now, but here we'll be discussing more of problem-oriented analysis in this analog electronics. Analog electronics is more about analysis than just about just a theory part, right? So here, now you can see here, as we know, you have something called NPN transistor. NPN transistor you have. So here, one region is named as emitter, second region is going to be base, and third is going to be collector. Remember, always in between emitter and base, you will have a base, and the base will not be constructed with the same material which are used for emitter and collector. Always remember, emitter and collector will be of same material. I mean to say, same kind of semiconductor means P-type or N-type. Same type of semiconductor means either both emitter and collector will be either P-type or N-type. In between them, you will be having something called base. In between them, you will be having something called base, and so which will be having other type of the semiconductor material. Yeah, I'll come back to that question, small signal analysis. I'll come back to that question called small signal analysis. Preetham, just give me a second. Just give me few minutes. I'll come back to your question. Definitely, I'll come back to the question. And this is the symbol of BJT. So symbol of the BJT consists of again base, emitter, collector. If it is P-type, always remember the arrow mark always represents. The arrow mark represents. This arrow mark represents the conventional flow of current. Always current flows from P to N region. Always current flows from P to N region. So then this type of semiconductor, this type of bipolar junction transistor is called NPN. NPN. So you have another type of semiconductor material, that is PP. In between that, you will have a N-type material, that is another BJT. Another BJT you will have. So what is the BJT? Is again, symbol is this. What is that, sir? Emitter, base, collector. Always current flows from base to emitter. P to N. Here, this is going to be the arrow mark represents current flowing into this. Right? Most of the times, what you need to remember is, so generally what happens is, there is operation. The diode will be, the transistor will be operated in active region. Generally, it will be used in active region. So in that active region, there is one current, that is emitter current is always equal to base current plus collector current. And the voltages here will be called as, if this is positive, emitter is more positive because P is saying, so I can call this as a VEB current, VEB voltage, which is going to be plus or minus. If this is an NPN transistor, if you go back and see, if this is going to be, so as current is flowing here, so I can call this as a VBE. This is an NPN. So here plus and then minus. This is voltage. And this voltage is called VCE. Remember always this. So VB and VC are the two voltages which are very important. VB and VC are the two voltages which are very, very important. So base, emitter, collector. base emitter collector is what it's going to be. And the current, as I told you, the emitter current is always, IE current is always equal to that. I mean to say, when in active region, so when a one current is going in, the two currents are going out. If one current is going out, that is emitter current is going out, and two currents will be coming in. So always remember, for active region, so IE must be equal to IB. IE is equal, must be equal to IB plus IC. It also will be the same. So still you will have collector emitter voltage. So as this is P type and this is N type, and the current is flowing here, so it is going to be plus and minus. Plus and minus. So if the current is going in here, if the current IE is going in, then two currents will be going out. That is IB and IC. Two currents will be going out, IB and IC. Remember this point very clearly. Remember this point very clearly. Okay, so I is equal to IB plus IC. I is equal to IB plus IC. I is equal to IB plus IC. Now we will discuss the point. What is our small signal analysis? What is small signal analysis? What do you mean by small signal analysis? So first we'll discuss what is small signal, and then we'll talk about analysis. So first we'll talk about what is small signal, then we'll talk about this analysis. What do you mean by small signal? Small signal. Remember this point. When there is small signal, similarly we have something called large signal also. Large signal also. Sir, as an electronic student, as an electronic guy, so we should not much bothered about higher voltages, right? To differentiate between these two small signal and large signals, we should have a reference voltage. What is the reference voltage is? We will always consider Vt as a reference voltage. What is the Vt, sir? Volt equivalent temperature. Volt equivalent temperature. Thermal voltage, or you can call thermal voltage or volt equivalent temperature. Thermal voltage or volt equivalent temperature. Volt equivalent temperature. Yes or no? Yes or no? What is its value, sir? At room temperature, what is its value? At room temperature, at T is equal to 300 degrees Kelvin, at T is equal to 300 degrees Kelvin, this Vt is going to be how much? It's going to be generally 25.9, or we can say 26 millivolts. 26 millivolts. So any voltage which is less than this voltage, which is less than Vt, is called small signal. It means what is this? This is going to be 26 millivolts. So I can have a 2 millivolts, 10 millivolts, 20 millivolts. So any voltage which is less than 26 millivolts is called as small signal. So any voltage which is greater than 26 millivolts is called as a large signal. So what do you mean by large signal? Let's say you will talk about 0.1 volt, we talk about 5 volts. Generally we don't talk about volts. Generally we will not talk about 0.1 volts, and you'll have let's say 50 millivolts. So all the voltages can be made which is greater than 26 millivolts is called large signal. Hope your point is clear. Hope your doubt is clear, Preetham, now. So remember, any voltage which is less than 26 millivolts is called as small signal. Any voltage which is greater than 26 millivolts is called large signal. Then what is mean by analysis? What do you mean by analysis? So in general, the word analysis stands for so you will apply the small signal voltages to the given circuit, and you'll try to find out the voltages and currents in the circuit. Currents calculation. The calculation of voltage and currents for a given, or so if somebody says design, so there is a difference between design and analysis. So design. So what do you mean by design? So in case of analysis, all the components will be given. all the components will be given. Okay, all the components will be given, but you need to calculate the values of voltage and currents in a given circuit. You need to calculate the values of the voltage and currents in the given circuit. But whereas in design, you need to calculate the components. So calculate the components, calculate the components, calculate the components with by giving the voltage, and voltage and currents will be given. Voltages and currents will be given. Currents will be given. Yes. So remember all these points. Remember all these points. So analysis and design. What is small signal and what is analysis and design? So these are all what the concepts to be remembered. So one thing you need to remember here is always there is some standard values, which you need to remember. Here the current equations. Before going that, before going to that, so I'll also try to explain you. So what do you mean by the some currents, some values you need to remember. Some values you need to remember is always remember emitter current is equal to a base current plus collector current IC. So point number one you need to remember is emitter current I is equal to IB plus IC. Emitter current is equal to base current plus collector current. And you have something called alpha, which is called amplification factor of a common base. So in case of common base, alpha is going to be what, sir? IC by IE, or you can say IC is equal to alpha times of IE, alpha times of IE, which you need to remember. And you have something called beta. So most of the times we'll talk about alpha and beta. I will not talk about gamma, but beta is going to be what, sir? Current amplification factor of a common emitter amplifier. For a common emitter amplifier, so what is the output current? Current is going to be I see the base current, input current is going to be B. So I can call IC is equal to beta times of IB. This you need to remember. So this you need to remember. So these are the simple formulas which you need to remember. Right? The standard values of alpha always ranges from actually 0.9 to 0.99. Sometimes we call this as alpha is equal to 1. So the fifth point is going to be beta. Beta is always ranges from 50 to 500. 50 to 500. 50 to 500. It will range from 50 to 500. So these are the things which you need to remember. Similarly, VBE is equal to simply 0.7 volts. 0.7 volts for silicon and 0.3 volts for germanium and 0.3 volts for germanium. So in general, VB is going to be 0.7 only. 0.7 only. And then, so you have something called VCE SAT, and VCE is going to be 0.2 volts when VCE is going to be 0.2 volts when in general, when it is in the active region or in the saturation especially. VCE SAT, we call this as a VCE SAT is going to be 0.3 volts. All of this theory is not I'm going to teach here because it is nowhere related to or discuss about all those things here. Okay. So this point you need to remember. So a few points which you need to remember all this. So why I am discussing all these things here now? Because so these are the things you need to remember. These are the basic things you need to remember, sir. These are the basic formulas which you need to remember to calculate all the problems of what we are going to discuss in the next 1 hour. Probably in the next 1 hour, what we are going to discuss is all the problems. So now we'll quickly move on to the problems and we'll try to see. So from the previous gate examinations, most of the problems are from previous gate examinations only. Right? So this problem is, I think, which was asked in 1995 or something. A very old problem, but very good problem. This is a very, very good problem. Now you can see here the transistor in the figure having a high value of beta. Sir, remember this very important thing. I'll come back to this point. Something called high value of beta. High value of beta is very, very important. I'll talk about this. Whenever the question if he says high value of beta, so he has given some clue. For you to calculate. he has given some clue to calculate the value. This I value of beta is some clue. Okay, and he's saying VB is going to be 0.65 volts. The current I flowing to 2 kilo ohms resistor will be. So he's talking about, he's asking us to calculate the value of I. He's asking us to calculate the value of I. So remember, whenever he's saying beta is very high, beta is high. So whenever he says beta is high, means, so just now we have discussed, we know that IC is equal to beta times of IB, sorry. Beta times of IB. Yeah. So IC is equal to beta times of IB. IC is equal to beta times of IB. This is a very important formula which we have discussed. So IC is equal to beta times of IB. So what is going to be beta? Beta is going to be IC by IB. So when can beta will be very high? When can beta will be very high? It means it is almost equal to infinity. Beta can be infinity only when IB is equal to approximately equal to 0. So this is the clue which he has given, sir. This is the clue which he has given. Remember, in the given problem, whenever the examiner says, high value of beta means, so IB is going to be 0. IB is going to be 0. And he also told, so VB is going to be 0.5 volts. So now what we can say here is, so for the all the transistors is saying, for all transistors, when IB is equal to 0 means this base current IB is equal to 0. And this base current IB is also equal to 0. IB is also equal to 0. Now is asking us to calculate the value of I. So if you understand, assume that this is going to be Q1, this is going to be Q2. So I can say this is going to be IC1. Yes or no? This is going to be IC1. This is going to be IB1. This is going to be IB2. And I can call this as IE1. This is going to be IE1. So now this is going to be, I can call this as IE2 because this is going to be current which is flowing to the emitter of the, so here IB2 is equal to 0. Now I can say this is going to be IC2. See, just by giving this statement, a high value of beta, so he has told something very interesting, sir. So we know that just now we have discussed IE is equal to what, sir? So IB plus IC is what we have discussed. So when IB is equal to 0, can I write IE is almost equal to IC? Is almost equal to IC. But what is asking, sir? Is asking us to calculate the value of the current which is flowing to 2 kilo ohms means IC1 is asking. So now you can see here. Now I'll try to read the circuit here. So whenever IC1 is asking, so what is asking, sir? Is asking for IC1. IC1 is equal to how much? IC1 is equal to how much? So if IC1 I need to calculate, can I say is this same as IE1? Yes or no? So IC1 is equal to IC1 because IB1 is equal to 0. So I can I say IB1 is equal to IB1 plus IC1. So IE1 must be equal to IC1. IE1 must be equal to IC1. So whenever IC1 is equal to IE1, whenever IC1 is equal to IE1, what we can say, sir? So can I say this must be same as that of IC2? This is same as that of IC2. So when this is same as IC2, because IE1 and IC2 are flowing the same direction, the same line, right? So both of them are same. So IE1 must be equal to IC2. Now what we know that, sir, IE2 is equal to IB2 plus IC2, but IB2 is also 0. IB2 is also 0. So when IB2 is also 0, now can I say this IC2 is equal to IE2? This IC2 is equal to IE2. So I can calculate any one of them. To calculate the value of IC1, I can calculate IE1, IE2 or IE2, IC2 or IE1. Whichever is I can calculate, I can get the value of IC1. I can get the value of IC1. So very simple. Now as the base current is flowing to this IB1 and IB2 as 0. So now what happens, sir? What if the voltage which you are applying will just create a current which is flowing to this, right? So can I if you apply KVL, if you apply KVL or redraw the circuit, so how the circuit looks? The circuit looks like this. Very simple. So how many resistors we have? 1, 2, 3. So if I am able to calculate the value of this current, let's say this is going to be current voltage V1, and I'm going to call this as a voltage V2, or I can call this as a VB2. VB2. If I can able to calculate the value of VB2, I can get the value of VB2 here, and we know that this voltage VBE, what is mentioned, sir? It is clearly mentioned. It's going to be 0.65 volts, and it's going to be VE. If I can able to calculate the value of VE by calculating the VBE, so now we know that VBE is equal to VB minus VE. So VB is going to be VE minus VB. Now, if you want to calculate, so VE value simply it will be VB minus VBE. VB minus VBE. So now I can say VBE2 is equal to VB2 minus VE2. So to calculate the value of VE2, what can I do, sir? I can calculate VB2 minus VBE2. So my major aim is to calculate VB2. My major aim is to calculate VB2. So how can you calculate VB2, sir? Very simple. Now here you have 10 volts, and this resistor, I think, how much is the resistance? So it's going to be 6.5, 1.85, 1.65. So 6.5K, 1.85K, and then it's going to be 1.65K. So this is the voltage which I am trying to calculate. I can call this as a VBE2. So simply what I can say is this. Can I simply apply directly what is going to be VB2? So VB2 is equal to total voltage 10 volts, and then its corresponding current resistance 1.65K by so you're going to have a total resistance 6.5K plus 1.85K plus 1.65K. So total I think it's going to be 10 by 10 into 1.65K by 6.5. This is going to be 1.67555 3.5. This is going to be 3.5 and 6.5. 3.5 is going to be 10K. So 10K. So K will get cancelled. K will get cancelled here. So when K and K will get cancelled, and V and this 10 and 10 get cancelled. So what will be remaining, sir? So you will have the voltage VBE2. VBE2 is equal to what, sir? You will get 1.65 volts. Now, what should I calculate? I should calculate the value of VE2. So, what is VE2? VE2 is equal to VBE2. So, this is going to be VB2. Actually, I should say not VBE2. I'm just sorry. I should say this is going to be VB2. So this VE2 is going to be VB2 minus VBE2. So what is this voltage you got, sir? You got 1.65 volts, and then how much is your VB2? In the given problem, it says it's going to be 0.65. It's going to be simply 0.65 volts. So 0.65 volts. So what is going to be VE? VE2 is going to be simply 1 volt. Now, if we calculate the value of VE2, you can calculate the value of VIE2 very easily. What is that, sir? It's going to be VE2 by RE2. So how much is the VE2, sir? VE2 is going to be 1 volt by how much is going to be RE2? It's going to be 1K. Very simple. It's going to be 1 kilo ohm. So IE2 is going to be 1 milliamp. So as we know from here, if you can able to calculate the value of IE2, IC1 is same. So as IE2 is equal to IC1, so then it's going to be 1 milliamp. So what is the answer, sir? What is the answer which you are expecting? This is going to be the answer which you are going to be get. Sir, many other procedures are also there. In the many other procedures, what is there, sir, is so generally what happens, sir? In other procedures, what they will do is they'll ask you to calculate all the Thevenin's equivalent, all these things. Not required, sir. All those things are not required. All those things are not required. It's very simple. It's very simple. So IE it is going to be IC1. This is the very important problem. This is a very, very important problem from the previous gate examinations. This is a very important problem from the previous gate examinations. So next we'll see the next problem. So in the amplifier circuit shown in the figure, the values of R1 and R2 are such that the transistor is operating in at Vc is equal to 3 volts, and Ic is equal to 1.5 milliamps. Okay, then its beta is going to be 150. So for the transistor with the beta is equal to 200, what is the operating point? So he's asking us to calculate simply what is going to be VCE and IC. VCE and IC. So VCE and IC are the DC values. Remember always remember VCE and IC are DC values. So when you want to calculate the DC values, all the AC components must be short circuited. All the AC component must be short circuited. So look, to calculate this, so capacitors should be short circuited. You not worry about these two capacitors. Just to confuse you, he has given. So what he's asking, sir, is actually asking about the VCE and IC, but you don't know the values of R1 and R2. You don't know the values of R1 and R2. So to calculate the values of R1 and R2, what you need to do, sir? But first, let me redraw. Let me redraw this circuit. So how the circuit looks like? The circuit looks like, sir. Simple. I'll try to draw very simply. So this is a very simple circuit. So he's asking R1 and then R2, and here what is the voltage he has given, sir? He has given a voltage of 6 volts. He has given a voltage of 6 volts, and what he's saying, sir? He also given another clue. He's saying VC is going to be 3 volts. So VC is going to be 3 volts means, so this voltage he has given. Because this is collector, base, emitter. So it's going to be VCE is equal to 3 volts he has given. 3 volts he has given, and he also given some current IC. So this current IC is equal to how much he has given, sir? 1.5, I think milliamps. Yeah, 1.5 milliamps he has given. He's also given the values of beta. Beta is going to be initially 150. For 200 is asking. For beta value equal to 200, he is asking us to calculate the value. So simple, sir. Don't think that the problem is very difficult. First thing is you need to calculate the values of R1 and R2. If you can calculate the values of R1 and R2, you can calculate the VC and IC very easily. Okay. Now how to calculate this, sir? From the given data. So whenever he has not given anything, assume always this is going to be VBE is going to be. So this VBE is going to be, as I told you, standard value is going to be 0.7 volts. Standard value is going to be 0.7 volts, which I have already told. Now let us calculate the value of. Calculate the value of the base current IB. So why, sir? Because we know the values of beta and IC. So when you know the values of beta and IC, so what is going to be IB? We know that IC is going to be beta times of IB. So from this, what they can calculate? First, I can calculate IB is equal to IC by beta. So what's the value of IC? He has given is going to be 1.5 milliamps. By beta is going to be 150. So what is going to be IB, sir? Can you quickly calculate what's going to be IB? Calculate it. Not responding? Okay, I'll do one thing. It's going to be 0.01 milliamps. 0.01 milliamps is going to be the 0.01 is going to be the IB value. So you know the value of IC and you know the value of IB now. Just a second. Yeah. Now you are able to calculate the value of IB. IB is going to be 0.1 milliamps and IC is going to be 1.5 milliamps. Now it is very easy for us to calculate the values of R and R2. Simply apply KVL, sir. Apply KVL. So if you want to calculate the value of R1, apply KVL to this loop. So how much is going to be VBE? We know it's going to be 0.7 volts. 0.7 volts. So apply KVL to the this input side loop, that is R1 loop. Correct, Srinivas Rao? 0.01 milliamps. Correct, Srinivas Rao? Correct, your answer is right. Now simply apply KVL to this loop. So see, if you apply KVL to this loop, what you get, sir? So let's assume this is going to be IB current. IB current. So this is going to be, so what you'll get, sir? Simply you'll get 6 minus IB into R1 minus 0.7 is going to be 0. So R1 is going to be directly, I'll write R1 is going to be 6 minus 0.7 by IB. This is going to be 5.3 by IB is how much, sir? IB we got is 0.01 milliamps. So 0.01 milliamps is what is going to be R1? So it's going to be 0.10 to the power of 5. 10 to the power of 5, 10 to the power of 5 means, so 5 into 10 to the power of 5.3 into 10 to the power of 5. So I can simply call this as a 530 kilo ohms. 530 kilo ohms is the resistance R1. 530 kilo ohms is the resistance R1. Now what's R2? To calculate the value of R2, apply KVL in the outer loop. So apply KVL in the outer loop. How's that? So it's going to be 6 volts. 6 volts minus ICRC minus 3 volts minus 3 volts is equal to 0. So what you need, sir? RC, actually R2 I should say. R2 is going to be 6 minus 3 by IC. So how much is this? 0 to 3. What is how much, sir? 1.5 milliamp. 1.5 milliamp. So how much is going to be R2? R2 is going to be 2 kilo ohms. Very simple. Yes or no? You'll get R2 is going to be 2 kilo ohms. So once you get the values of R2, it is very easy for us to calculate the required values. So what is the new circuit, sir? So new circuit is going to be like this. New circuit is going to be like this. This is going to be 6 volts. Sir, these are the very important problems which will fetch you at least 1 to 2 marks in the GATE examinations. So 1 to 2 marks is also very, very important in the every even a half mark, 0.5 mark is also very, very important. There are students who loses central government jobs just because of not having 0.25 marks. I have seen the students who lost many jobs because of not having just 0.25 marks. So it will be painful. So don't miss this. Don't miss this, sir. So it's going to be 530 kilo ohms. 530 kilo ohms, and then this is going to be how much, sir? 2K we got, and the beta. What is asking, sir? Is asking if I change the beta value going to be 200. So what is its corresponding IC, and is also asking us to calculate the current corresponding values of VCE. VCE, very simple. Very simple is asking. Very simple is asking. So first what I need to calculate, sir? First what I need to calculate is again base current and collector current. If I can able to calculate the value of base current, I can calculate the value of IC because IC is equal to be beta times of IB. So to calculate IB, apply KVL. Apply KVL in the outer loop. So or inside, whatever. So simply what you get, sir? 6 minus IB into 530K minus 0.7 is equal to 0. So I can directly write IB is equal to be, so 6 minus 0.7 is going to be 5.3 by 530K. 5.3 by 530K. So what you get, sir? How much IB you are going to get? How much IB you are going to get? Will you please calculate it quickly? What is the value of IB you will get, sir? What's the value of IB you will get? It would be great if you can calculate the value quickly. 5.3 by 530K. I again will get IB value same, sir. What is that? You will get 0.01 milliamps is the value what we will get. 0.01 milliamps is going to be what you'll get. So from this you need to calculate the value of IC. So how to calculate IC? Very simple. IC is going to be how much? IC is going to be how much, sir? IC is going to be beta times of IB. So how much is the beta? Beta here now is going to be 200. It is 200 and IB is how much you got, sir? 0.01 milliamps. So how much IC you are going to get? How much IC you are going to get? So I can say it will be 2 milliamps. 2 milliamps. 2 milliamps. Yes, Srinivasa, you are right. Yes, Srinivasa, you are right. You will get the same value. So IC is going to be 2 milliamps. What you will get? So once you know the value of IC, now it is easy for us to calculate what is VCE. So to calculate VCE, so this is what he asked, right? To calculate a VCE, apply KVL. Apply KVL in the other loop. KVL in the collector loop. I should say collector loop. So if you apply the KVL in the collector loop, what you'll get, sir? You'll get VCC minus ICRC minus VCE is equal to 0. So from this, VCE is equal to VCC minus IC into RC. So what is the VCE then? So then VCE is going to be, VCC is how much, sir? How much he has given VCC? 6 volts he has given. 6 volts VCC minus, I should say just 6 minus, how much is IC we got? 72 milliamps, 2 into 10 to the power of minus 3 into how much is the resistance R2 we got? R2 how much? To 2K. R2 is going to be 2K. So 2 into 10 to the power of 3. So plus 3 and minus 3 will get cancelled. So what will get, sir? 6 minus 4. So VCE is going to be 2 volts. 2 volts. So what is asking, sir? He is asking us to calculate the values of VCE and IC respectively. So it's going to be 2 volts and 2 milliamps. 2 volts and 2 milliamps. So what is the option, sir? Which option is the right answer? Correct, Srinivas Rao. Correct, Srinivas Rao. So which option is the right answer? Which option is the right answer? Option A is the right answer. Option A is the right answer. Option A is the right answer. Okay. Okay. This is a very simple problem. This is also a very simple problem. Correct. Correct, Srinivas Rao. So option A is the right answer. 2 volts and 2 milliamps is the right answer. 2 volts and 2 milliamps is the right answer. Correct. Correct. Now we'll see the next problem. Hope you are getting all the points. Hope you are getting all the points. So if you are unable to get any point, let me know immediately. Let me know immediately. Okay. Let me know immediately. Now we'll see this problem. It's also a very simple problem. It's also a very simple problem. A NPN transistor connected in as shown in the figure. So VB is going to be 0.7 volts. What is saying, sir? It's going to be 0.7 volts. He's saying, okay, 0.7 volts. He's saying, given that the reverse saturation current of the junction at room temperature. So he is saying I naught, I think can I call this IS? Saturation current is going to be 10 to the power of minus 13 amperes. And he's asking us to calculate IE. He's asking us to calculate the value of IE. He's asking us to calculate the value of IE. So simple, sir. So simple. It is very, very simple. It's very simple, sir. Whenever you if you look at the equivalent circuit, now what happens, sir? So this is going to be, just for my convenience, I am trying to draw this. So this is a some. So now what happens, sir? This is short circuited. This is base, right? Base, emitter, and then collector, Now you can see, whenever this is short circuited. So what is the use of having this diode? What is the use of this having this diode? So now this transistor acts like a simple diode. Transistor is acting like a simple diode. So I can say very simply, it's going to be simply like this. Emitter is going to be base, is going to be collector. So I can write it's going to be IE. So what is this IE, sir? Is it not the current flowing through diode? Is it not the current flowing through diode? So IE current is nothing but the reverse saturation current which is flowing through it, and e power VBE by eta Vt minus 1. Eta Vt minus 1. So Is is given, Vb is also given, Vt is also given. Vt is 300 degrees centigrade, means 300 degrees Kelvin, means what is going to be Vt? Vt we should calculate. Eta is not given. When eta is not given, assume that it's going to be eta is equal to 1. So very simple. So Is here is given. So sorry. So Is is going to be 10 to the power of minus 13 amperes, and Vt is equal to 26 milliamps. Sorry, millivolts. Oh, I'm sorry, 26 millivolts. And then what remains, sir? Vb is also given. Vb is also given. It's going to be 0.7 volts. So simply the emitter current I is going to be 10 to the power of minus 13 into e power 0.7 volts by 26 into 10 to the power of minus 3 minus 1. So can you please calculate what is this IE value? Is asking, anyway, in milliamps he is asking emitter current IE. Can you please calculate this? Can you please calculate this and let me know what is the answer? Let me know what is the answer. Very simple question. Very simple question. The only thing is the logic here you should know here. Whenever this base and emitter, base and collector are short circuited, whenever base and collector are short circuited, this acts like a simple diode. This acts like a simple diode. Sir, even if base and emitter are short circuited, so this also acts like a diode. So this is very important. So this is very important. How it is transferred. So how it happened. Now you can see this point is very important. This point is very important to remember. So calculate what is this value. 10 to the power of minus 13 into e power 0.7 by 26 milli minus 1. So what would be the right value? What would be the right value? So the right value of I is going to be 49 milliamps. 49 milliamps is the answer. So what is the option, sir? Option C. So option C is the right answer. 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 Okay. Option C is going to be the right answer. Option C is going to be the right answer. Okay. Now this is another super problem which has given. Just see the problem and think what is talking about. Everyone feels very scared when he sees such kind of problems. Don't get scared. Don't get scared. Just think the problem. What is the problem, sir? In the circuit using BJT, with the beta is equal to 50, VB is equal to 0.7 shown in the figure. The base current IB and collector voltage by VC respectively is asking us to calculate the values of. Is asking us to calculate the values of IB and VC. So he's asking us to calculate the values of this current IB, current, and is also asking us to calculate the value of voltage VC. This is voltage VC. So, sir, IB and VC are the DC voltages. IB and DC are the VC are the DC voltages. IB and VC are the DC voltages. Are you there? IB and VC are the DC voltages. So you need not much worry about these capacitors. So whenever you're asking us to calculate the values of these DC voltage and DC currents, assume that this is going to be DC analysis. DC analysis. So in case of DC analysis, all capacitors must be open circuited. So now what happens, sir? It's very simple now. It's very simple. Now what happens, sir? The circuit will turn very simply. The circuit will turn like this now. So what voltage you have? 20 volts you have here. It's going to be 2K. It's going to be 430K. And this is going to be 1K. This is emitter. Now it is easy for you to calculate the value. What is asking, sir? Is asking us to calculate the value of IB, and then is also asking us to calculate the value of VC. So and he has given, so beta is going to be 50 and this VBE is going to be 0.7 volts, 0.7 volts, 0.7 volts, 0.7 volts. Okay. Now simply first apply this current is going to be IB current, this current is going to be IC current, and this current is going to be IE current. This current is going to be IE current. IE current. So these are the very important things to be remembered, sir. So don't get scared about the circuit which you have seen, right? So to confuse you, he has given all these things. So actually the problem is very simple. Simple analysis to calculate the values of base current and collector voltage VC. So now look at this. Simply apply KVL here. If you apply KVL, what you can get, sir? You can say VCC minus here IBRB. Let's say this is going to be RB. IBRB plus 0.7 and IE is going to be this. IE into 1K. So I can say, if you want me to write, I'll write it directly. So without wasting much time, because time is very important for us. So it's going to be 20 volts. So 20 volts. I should waste why to write 20 minus. So you don't know the value of IB, but you know the resistance value. What is the resistance value, sir? 430K, I think he has given. How much he has given? 430K, and then it's going to be 0.7 volts. So minus 0.7 volts minus IE into 1K is equal to 0. So here it's going to be 20 minus 0.7. So it's going to be 19.3 minus, so 430K into IB minus 1K into IE. 1K into I is equal to 0. Sir, can you write IE is going to be what, sir? IB plus IC. Right? So we know that IE is going to be IC plus IB. But what is IC, sir? IC is beta times of IB or not? So if I replace IB is going to be, so beta IB plus IB. So can I write this? Going to be beta plus 1 into IB. Good evening. Good evening, Ravindra sir. Good evening. Okay. So I is going to be beta plus 1 into IB. So just substitute here. Substitute here. What will get? What will get here? So here 19.3 minus, so 430, sorry, I'm just sorry, I have, okay. So 430K into IB minus 1K into, so beta plus 1 into IB. Beta plus 1 into IB. How much is the beta given? In the given problem, beta is going to be 50. The given problem, beta is going to be 50. So simply now substitute all the values, you'll get beautifully whatever required. So you bring it this side. So 19.3 is equal to, so 430K into IB plus, so shall I write directly? So 51K into IB. So now can you calculate the value of IB? IB is simply 19.3 by, so 430K plus 51K. So can you please calculate this? So how much is going to be IB value? How much is going to be IB value? How much is going to be IB value, sir? IB value, what you're going to get is you're going to be 40 microamperes. So because I have already calculated, I'm writing. So IB is going to be 40 microamperes. IB is going to be 40 microamperes. So from IB, you can calculate the value of IC. IC is going to be beta times of IB. What's the value of beta? Beta is going to be 50. 50 into 40 microamperes is going to be how much? So IC is going to be how much? It's going to be 50 to 2000 microamperes. Can you write simply 2 milliamps? So if you can able to calculate the value of IC, we can easily calculate the now value of VC. So what is asking, sir? Is simply asking us to calculate the value of, as IB I calculated. IB I already got. What is that IB, sir? IB is going to be 40 microamperes. So, but what I need to still calculate, sir? I need to calculate the value of VC. I need to calculate the value of VC. So to calculate the value of VC, what I should do, sir? Simply apply KVL. Apply KVL in the collector loop. Collector loop. I'm like to finish it quickly. That's the reason why I'm running like anything. I'm just running like anything because now apply KVL here. So 20K minus 2K into IC plus VC. Yes or no? So 20 minus, sorry, IC is how much here? I got 2 into 10 to the power of minus 3 into what is the resistance? 2K is going to be 2 into 10 to the power of 3 is equal to VC directly, I'll write. So VC is going to be 20 minus 4, so it's going to be 16. So VC is going to be 16 volts. VC is going to be 16 volts. Very simple problem. All the problems are very simple. Correct, Srinivas, your answer is correct. We got IC is going to be 2 milliamps. IC is going to be 2 milliamps. But what is going to be VC? All these are very simple. All these are very simple, sir. You people, once you see the problem, what happens, sir? People think that they are difficult. People think that they are difficult. Actually, they are not difficult, sir. They're all simple problems only. They're all simple problems only. Don't ever think that they are difficult. They are difficult. Only thing is you might have given some logic. Srinivas, you are right. Srinivas, you are right. Srinivas, you are right. Right? Let's move on to the next problem. Let's move on to the next problem. Okay. Yeah. This is the problem which I have given. In the circuit shown below, the silicon is clearly saying silicon NPN transistor Q has very high value of beta. Whenever I see this word, very high value of beta, the problem will become very easy. The problem becomes very, very simple. the problem becomes very, very simple. So the required value of R2 in kilo ohms to produce IC is equal to 1 milliamp. See, the two logics, this itself, this very high value of beta itself will boost us to solve the problem very quickly. So as I told you many times, whenever there is a word called very high value of beta, so what is, sir? When the beta is very high, beta is very high means what we know, sir? We know that IC is equal to beta times of IB. So IB is equal to how much? IC by beta. As this value of beta is very, very high, now what happens? Very, very high means let's assume it's going to be infinity. So IB is almost equal to 0. This is the logic which I have given. So when IB is equal to 0, now what is there, sir? We can say I is equal to IB plus IC actually. So whatever I say, so I is equal to how much? Is going to be IC. I is going to be IC. I is going to be IC. This is very important. Now assume this is going to be some. If you can able to calculate the value of VB here and what is the current flowing through this, because when IB is equal to 0, so whatever current which is flowing through R1, same current will flow through R2. So now what we need to do, sir? We need to calculate the value of VB and what is the current flowing through this. So if we can able to calculate these two values, so I can simply calculate what is R2. So he's asking for R2. R2 simply VB by the current I. Let's assume this is going to be current I. So VB by I. So now our job is to calculate. Correct, Srinivasa, you are right. You are very sharp. That shows you are very interested and listening to my classes. That's good. So R2 is going to be VB by I. So now our duty is to calculate the value of VB and the current I. VB and current I. So, but already has given IC value. When IC value is given, now I can able to calculate the value of VE. So if I can able to calculate the value of VE, I can calculate the value of VB. Sir, VB is how much, sir? So as I told you, whenever VB is not given, assume VB is going to be 0.7 volts. Now assume so VBE is going to be by default 0.7 volts. So let's say in the given problem, if he mentions VBE is going to be 0.65 volts, you should take VB is equal to 0.65 volts or 0.6 volts, whatever he mentions. If he is not given any value, remember you should assume that VB is going to be 0.7 volts. VB is going to be 0.7 volts. Now what's my job? My job is to calculate this now. So what is VBE? So VBE is going to be actually VB minus VE. Now I know value of VB and VE, so I should calculate the value of VB. So VB is going to be VBE plus VE. So how to calculate the value of VE, sir? How to calculate the value of VE? Do you know the value of VE? No, you don't know. But you know the value of the current flowing through this, IE and RE. So I can write VBE is going to be VBE. I shall write directly 0.7 volts. Why to write VBE these many number of times? Simply, so 0.7 plus is going to be IE into RE. So this is going to be 0.7. So I can write IE is equal to IC into RE. So it's going to be 0.7 plus how much is IC is given? IC is given 1 milliamp. 1 milliamp. This is going to be 10 to the power of minus 3 into RE. How much is given? RE is going to be 500 ohms. So shall I write simply 0.5 kilo ohms? So that it will be easy for me to calculate. So 0.5 kilometers, this get cancelled. I mean to say this 10 to the power of plus 3, 10 to the power of minus 3 will get cancelled. 10 to the power of plus 3 and minus 3 will get cancelled. So what I am going to get is going to be 0.7 plus 0.5 is going to be VB. So I can write VB is going to be 1.2 volts. 1.2 volts. So when I'm getting VB is equal to 1.2 volts, now my job is to calculate the value of I. So I will calculate the value of I. I will calculate the value of I. I will calculate the value of I. Very simple. Here you have 3 volts. Here you have some voltage. How much voltage you got? You got 1 volt or something. You got 1.2 volts. Now I is going to be, I shall write, is going to be 3 volts minus, why to write V? 3 minus 1.2 by its corresponding resistance 60k. Corresponding resistance 60k, 16 10 to the power of 3. So how much is going to be I, sir? I is going to be how much? It's going to be 2.8 by 60 milliamps. So can you calculate what is the value of I? Calculate the value of I. Some current will get, some current will get. Now what was the same current is flowing. So otherwise, you can, if you want to do it something different, you can do it something different also, sir. So what you can do, sir? Total voltage is here. Total voltage is here, and you can simply calculate. You know, not even you know the value of VB, right? VB. I have one more formula. What you can do, sir? VB is going to be total voltage V into R2 by R2 plus this 60k. This also you can do without calculating this also. So how much value of VB? VB is going to 1.2. This is 3 into R2 by R2 plus 60k. 60k. So do it very quickly. You'll get some value. So now if you calculate this, you can easily get the value of R2. So I'll try to write. Is going to be 1.2 by 3 is going to be R2 by R2 plus 60. So how much 3 ones are 3 fours are? Something will get. So you can calculate now this is 60k. So can you please get the value of this? So please calculate the value of R2. The R2 value which you are going to get is, I think, 40k. Calculate this, you'll get the 40k value. Okay. So what's the answer, sir? Option C is the right answer. Option C. You need to be very fast. You need to be very fast to do all these things, sir. You need to do all fast things. You need to be very, very fast. You need to be very, very fast to all these to solve all these problems. This is very important. Option C. Option C is the right answer. So okay, we'll move to the next problem. We'll move to the next problem. So what is the problem, sir? Consider the circuit shown in the figure. Assume that the base voltage VB is 0.8 volts and common base is going to be a unity. The value of collector to emitter voltage in volts. So what is saying, sir? Alpha is saying alpha. So VBE is equal to 0.8 volts, and alpha is going to be 1. What is alpha, sir? Actually, what is alpha, sir? Actually, alpha is equal to common base current again. That is alpha is equal to IC by IE. Is going to be 1. So from this, what I can say? I can say IC is equal to IE. IC is equal to IE. IC is equal to IE. So when IC is equal to IE, what is shortcut is saying, sir? When IC is equal to IE, what is the value of IB? What is the value of IB, sir? Simply, IB is going to be 0. Yes or no? Yes or no? IB is going to be 0. IB is going to be 0. Did you get the point or not? Did you get the point or not? So whenever IB is going to be 0, Now you should calculate the value of IC. If you can calculate the value of IC, you can calculate the value of VCE very easily. Very easily. What is that then? Now calculate the voltage across this point. This, let's say VB, and he also mentioned is going to be plus or minus 0.8 volts. This is going to be VE. Now, if you can able to calculate this, you can calculate the value of VE. From VE, you can calculate the value of what is IE. If you can able to calculate the value of IE, you can able to calculate the value of IC. So if you can able to calculate the value of IC, you can calculate the value of ECE. Very simple. Very simple. Very simple. Okay. Now we'll try to do it. We'll try to do it. We'll try to do it. So now assume what is the value of VB? VB is going to be the voltage which you are applying here. So this VB, VB is going to be the voltage. Complete, what is the output? Complete voltage 18 volts. Voltage divider rule, simply 18 volts into 16 by 16 plus 44 total resistance. So 16 plus 44. So VB is going to be how much, sir? 18 into 16 by not 60. So now calculate what is the value of VB. What's the value of VB? What's the value of VB? 16 into 16, 18 into, okay, 6 threes are 6 ones are 6 threes are 48 by 10, 4.8. So it will be 4.8 volts. VB is going to be 4.8. Now what is going to be VBE? V is going to be VB minus VBE. So you know it's going to be 4.8 volts minus 0.8 volts. So V is going to be how much? Simply V is going to be 4 volts. So when V is going to be 4 volts, what is going to be IE? IE is going to be simply VE by RE. So how much will to be VE? V is going to be 4 volts. By RE is how much, sir? How much RE is given? 2K. Very simple. 2K. So IE is going to be how much, sir? 2 milliamps. So which is also same as that of IC. So IC is also equal to 2 milliamps. 2 milliamps. Now what is asking, sir? Is asking us to calculate the value of VCE. Is asking us to calculate the value of VCE. Sorry. He is asking us to calculate the value of VCE. So how will we calculate VCE, sir? How will we calculate the value of VCE? Very simple. Very simple. Very simple. Apply KVL to the outer loop. Apply KVL to the outer loop. Means what? Means what? VCC. Sorry. VCC minus ICRC minus VCE minus VE is equal to 0. So VCC minus ICRC minus VCE minus VE is equal to 0. So what we need, sir? We need actually VCE. So VCE is going to be VCC minus ICRC minus VE equal to 0. Sorry, is not 0, equal to 0, is not equal to 0. So by default, I'll write this equal to 0. So it is habituated. Now what is VCE? Simply VCE is going to be, how much is this VCC? VCC is going to be 18 volts. 18 volts minus IC is RC. IC is 2 milliamp into RC is how much? RC is going to 4K. So 2 into 10 to the power of minus 3 into 4 into 10 to the power of 3 minus VCE. VE is already got, we got 4 volts. 4 volts. This is not required here. So VCE is going to be 18 minus 2 into 4, 8 minus 4 going to be 18 minus 12. So VCE is going to be how much, sir? 6 volts. VCE is going to be 6 volts. Very simple. Very simple. Very simple. VCE is going to be 6 volts. Very simple, sir. So all these problems are very simple actually. All these problems are very simple actually. The only thing is you guys just to know. So for all the problems is this is same. Procedure is same. Procedure is same. You should know all these things. You should remember. Alpha is equal to 1 means IB is equal to 0, or if beta is very high means beta is very high means IB is equal to 0. So mainly many times what happens is this he will be given, he will be considered it as IB is equal to 0. This is a very important problem. You see, in many problems, in the previous case also, so many areas, the same assumption was there. That is, IB is equal to 0. IB is equal to 0. So all these problems are very simple problems. That's what I already told you. I think I have told you, repeat here. So this is, so when beta is high means IB is equal to 0. This relationship you should remember. If you guys remember this relationship, you can easily calculate many problems. All these problems which I am discussing are from previous gate only, sir. Are they difficult? Actually, no. Are they difficult? No, actually, no. They are not difficult at all. They are not difficult at all. All the problems are same. All the problems are same. All the problems are same and easy also. Easy also. Now I think we'll move on to the next problem. So the circuit shown VE is equal to 4 volts. The values of alpha and beta. He's asking us to calculate the value for alpha and beta, and he has given the volt as 4 volts. So 4 volts. So can you please try it? Can you please try it? I think you can try this problem. I think you can try this problem, and please let me know. Please let me know what is the values of alpha and beta. In the next class, we'll try to discuss. In tomorrow's class. So don't think that tomorrow is a holiday, but though tomorrow is a festival, still we will have the class, right? Without missing anything. So we will definitely have one class tomorrow. We'll have a one class tomorrow. But don't think that we don't have classes. Though we have a festival on Bogi, on Sankranti, on Kanuma also, we'll have at least one hour. So for our comfortness, not going for 1.5 hours, we'll have a class for 1 hour only. We'll have only 1 hour class tomorrow. Right? So consider this as a homework and let me know what is this. What is the value? So if you are unable to calculate this, we will discuss about this in the next class. If you guys are unable to calculate this, we'll discuss this problem in the next class. Is the point clear? Is the point clear? Sir, first you need to calculate the beta value, sir. If you can able to calculate the value of beta, you can calculate the value of alpha very easily. If you can able to calculate the value of this, you can calculate the value of beta very easily. Okay. First point is you have to calculate the value of beta. So first calculate the value of beta. From beta you can calculate the value of alpha. Okay. Is the point clear? Okay. Okay, we'll move on to the next slide. So as I told you, so I try to repeat again. Go for a plus subscription. So what are the benefits of plus subscription? Are you're going to have a live classes. You can attend all the crash courses available. And a weekly test also you can write. As I told you many times, writing weekly test is very important. And doubt solving sessions. Every 4th hour is going to be a doubt solving session, which I told you. Every 4th hour is going to be doubt solving sessions. The sessions will be in English and Hindi. Which is very important. No problem, Bharat. No problem. No problem. No problem. That is the reason why from tomorrow I'll have only 1 hour from 4 to 5. But don't miss the classes. But I think many students are not coming here. Many students are not coming here. I have seen many students like Jansi, Pavans, and all the students. Many students are not attending the classes. I don't know what is the reason. Probably same reason which you have mentioned. They might have academic classes also. There might be some clash. There will be some clash. Okay. No issue. No issue. No issue. Okay. Now English and Hindi class will be English and Hindi. You'll have you can attend something called rank improvement batch. So which will boost your rank rapidly. Which will boost your rank very rapidly. Okay. Now we have another subscription called Iconic subscription. The benefits of Iconic subscription, along with this plus subscription benefits, you'll be given a personal coach, and you'll have a study planner. You'll have a study booster sessions and a personal test analysis. This is my favorite, sir. This is a personal test analysis. For every test, after a test, you will be given in-depth analysis by section, question by question. Right? This is very important, and you will be given a preparatory study material also. Will be given a preparatory study material also, which is very important, right? So the fee structure, I'll repeat again, the fee structure for plus subscription is going to be 27,225 rupees, and for 12 months, and for 18 months, it's going to 34,650 rupees. For 24 months, it's going to 30,600 is fees, and you can use all this SVS10 as a promo code. SVS10 as a promo code to get 10% discount. To get 10% discount. For an Iconic subscription, you have 12 months and 24 months. But 12 months is going to be 45,225 rupees, and 24 months is going to be 66,600 rupees. So you'll get SVS10 as a 10% discount. Use this SVS10 as a 10% discount, right? So on all the classes which I am teaching, I'll be post all the notes in Gate English, Telegram channel. I think I did not post the previous 3 to 4 classes. Today I'll be posting all this. So in the Telegram channel, somebody was asking also all the notes. After finishing this class, I'll immediately post this Unacademy Gate English class, Unacademy Gate in Telegram channel. I'll definitely post these notes. You need not worry. So we have other YouTube channels also. We have YouTube channels like Creatix Gate ESE Instrumentation and Mechanical Engineering, Engineering Sciences and Production Engineering. We have a separate YouTube channel. So for Chemical Engineering and Civil Engineering, we have a separate YouTube channel, Unacademy Gate English, which is to target the majorly South Indian students, where I am teaching right now. On Unacademy Gate English. And we have something called Unacademy Computer Science. Unacademy Computer Science. This will also help the students of IT, Information Technology students also. And you have gate questions. This is also very important. All previous gate questions will be available on this gate. And you have electrical junction exclusively for electrical students. Okay. And these are the January month schedule which we have. So Nageshwara sir is teaching communication systems, is also teaching engineering mathematics. Venkatakrishna sir also teaching engineering mathematics. Myself, Shravan Kumar, is teaching unlock crash course on unlock electronics, which I am doing it. And the foundation for mathematics will be discussed by Venkatakrishna sir. And NLN Sharma sir will be discussing a course on foundation mathematics, foundation course for 2023 aptitude. Sorry, NL Sharma sir will discuss aptitude, and measurements will be taken care by Surendra Babu sir, and Bhanu sir is going to be taken care by electrical machines. Don't miss any of these opportunities. Okay. No, don't miss any opportunities. All these are very important. And thank you. Don't forget to like, share, subscribe the channel. Ask many of your friends to subscribe for this. which will help many students to crack the GATE examination, even ESE examination also. So I would request you to share this and subscribe and hit the bell icon to get all the updates. So to get the all updates. So okay, thank you. Again, we'll meet again tomorrow. And happy Pongal in advance. Happy Pongal in advance. Happy Bogi first. Actually, tomorrow is the most important thing for South Indians. That is the Bogi, Sankaratri, and then Kanuma. So I wish you all in very advance all these festivals. Right. Thank you. We'll catch up in the next class. Bye.